Okay, so today we are going to start 1.4 arithmetic sequences and series. And so, what is arithmetic? And the answer is anytime you see an arithmetic that you're looking for, that's going to be when it's adding or subtracting the same amount each time. So, adding or subtracting a common difference. So this one here, it says, is the sequence arithmetic? If so, what is the common difference and what would be the next term? So we're going to look, is there a common difference? So from 3 to 8, I would add 5. 8 to 13, I would be adding 5. Adding 5, adding 5. So each time I was adding 5. So this is arithmetic. The common difference would be this 5. So we would write D equals 5. The difference equals 5. And then what is the next term? Well, if the last term was 23 and we add 5 to it, we would get 28. So the next term would be 28. How could you write a formula to represent the sequence? So we took the previous term and then we added the common difference. And that equaled the next term. So if we write that in words, that's what we did. Now how can we write it in terms of this actual sequence to be able to find it every time? So the previous term we actually are going to write as a, and then you know how exponents are up here? We're actually going to write it like down here as a sub. So this is saying the previous term, and then we take that and we add 5, and that would equal the next term, so that would equal the a of n. So a of n is representing the term we're looking for, and then this is representing the previous term because we're taking the term we're looking for and subtracting 1, and then 5 is our common difference. Okay, and then looking at the next one, is the sequence arithmetic? So looking at it, are we adding the same thing each time? And yes, we're adding 3 each time. So yes, it is. And then it wants us to write a recursive and explicit definition. So recursive is going to be like we wrote up here, where you need the previous term. So let's start with that one. So recursive general form is a sub n minus 1 plus the common difference. And then you always state the first term because we need the previous term to find the next one. So that would be listed here. So the first term in the sequence is this 4. So we would write 4 here. And then we need to plug in the common difference, which we said is adding 3. So we're going to write a 3 here. And so this right here would be our recursive formula. Now it says to write an explicit. And so what is explicit definition? That is used to find any term. So you don't need the previous one. You can find it using any term number. So the general form is a sub n equals the first term plus n minus 1 times the common difference. So again, this is a sub n, which is the nth term. So this is the nth term. This right here is the first term. This n would be the number, the term you're looking for, and then the d is still the common difference. So we're going to leave a sub n alone, and then we're going to plug in the first term. So remember, that's our 4 plus, and then n minus 1 stays. We don't do anything with it. And then what our common difference is, which we said is that 3. And now we have to make sure we simplify it as much as we can. So we can distribute this here. So we would have 4 plus 3n minus 3. And then we can combine like terms. So this and this, we can combine those. So our formula is the a sub n, and then we have 3n, and then combining that 4 minus 3 would be 1. And so this would be our explicit formula. So explicit would be this right here. Okay, so now go ahead and pause and try the next ones. Okay, so for this one here, we had our first term is 25. And so we're going to see that in our recursive right here and our explicit right here. And then our common difference was subtracting 5. So here and here. Trying the next one. Next one you add 2 and then you add 3, so it's not arithmetic, so that one's done. So moving on to our example 2. We have a scenario of the high school auditorium, which has 18 seats in the first row, and then 26 seats in the fifth row. Find the number of seats in each row forms an arithmetic sequence, so it tells us it is arithmetic. And then it wants us to write an explicit definition. So if we're writing an explicit definition, we need to know the first term, and then we also need to know the common difference. So we need to figure out what our common difference is. And so if I have 18 seats in the first row, so this is the first row, then I have the second row, third row, fourth row, and the fifth row. And I know the fifth row is 26. I'm going to work backwards trying to find the common difference. So if I wanted to find this middle number right here, and I know that they're adding and subtracting the same, each time I can find the average in order to find that middle number. So I'm going to do 26 plus 18 divide by 2. And when I do that, I actually get 22. So here would be 22. So then I can work even more backwards and say, okay, well, what would be in between those? So 18 and 22, what's directly in between those? That would be 20. What's directly in the middle of 22 and 26? 24. So our common difference here is that I'm adding 2 each time. So my common difference is 2. And then my first term is 18. So I'm going to plug in 18 for the a of 1, and I'm going to plug in 2 for the common difference. And then I'm just going to simplify it. So I'm going to distribute, and I get 18 plus 2n minus 2. And then I'm going to combine like terms. So this 18 minus 2. So my explicit formula is 2n plus 16. How many seats in the 12th row? So if I know the 12th row, then I'm just going to take that 12, and that's going to be my n equals 12. So I'm going to plug in 12 here. So I have a of 12, so the 12th term, equals 2 times 12 plus 16. And so that would be 24 plus 16 would be 40. So there's 40 seats in the 12th row. Go ahead and pause and try the next one. Okay, so for this one again, 1 and then 2 was my first and last number, and then I found the middle one, and then I found the middle of that, and then I found the middle of that again to find the common difference was 0.125. And then I plugged in to get my final equation here. So now the next, so that's it for like just writing the formulas. And now we're actually going to jump into arithmetic series. And those actually have the same idea, as they still are going to be adding and subtracting the same amount. But now we're going to add a formula here that we're going to be using. And I'm just going to go ahead and write it in the middle. But the sum of n is the n divided by 2. And then the first term plus the last term, in parentheses, being multiplied to the n over 2. So this right here is something really important to keep at hand. It's going to be something we use each time. So with that being said, when it says what is the sum of the terms in the arithmetic sequence, we are going to be finding the sum of all of those. So you could do 1 plus 4 plus 7 plus 10 plus 13. However, as you get farther along, this series might be longer, or they might be really big numbers. And so this formula right here, we can use and just find the sum. So the sum of, we have 1, 2, 3, 4, 5 terms. So the sum of all 5 terms would be 5 divided by 2. And then our first term, 1, and our last term, 13. So again, the 13 came from the last term, and then the 1 is the first term, and then we have the n, which is the number of terms. So number of terms. And then doing this, we would have 5/2 times 14. And so the sum of all 5 terms is 35. Okay, go ahead and try the next 3, just plugging into the formula. Okay, so again, I just started by identifying the pieces I needed. So the number of terms, the first term, and the last term. So that's what I did first on all of them. I identified the numbers that we needed, and then I plugged in. So I plugged in 6 here for n, and then 2, and 22 for the first term and last term, and then I just simplified. So that's it for today, and I look forward to seeing you in class.